we're going to take a big step forward in chemistry by discussing the mole. Now, I'm going to caution you on this. You need to really focus on this. It's a fairly short video, but there's a lot of information packed into it, and it's going to carry over to a lot of things throughout a good portion of this class throughout the school year. You'll have to have a periodic table in front of you as we go through this and as you do your practice problems. All right, so let's talk about the average atomic mass unit that we just dealt with. The average atomic mass is the average of all the isotopes with masses that are determined by the number of protons and neutrons. Because the electrons don't really have an effect upon the overall mass. They are so small compared to the mass of a proton or neutron that we just count the number of protons and neutrons for an isotope, and then we give it a label of atomic mass units or AMUs. Now, that's all fine and dandy because it adequately describes what's going on. We find the average atomic mass, we add up all the isotopes and the percentages we had for each of them, and then we came up with a value, and the value was the same, had the same label as the label of the isotopes, which was atomic mass units. The issue with that, you can't go into a lab and measure something in atomic mass units. Now, since we were talking about one atom at a time, this is an exceedingly small value. And there's a scientist in the 1860s by the name of Amadeo Avogadro who had this problem that we just discussed. How can we change these numbers into grams? So what he did, he had an idea of what to do. He did a lot of calculating, a lot of determination of the number of atoms it would take to change like 1.00794 AMUs into 1.00794 grams. How many atoms does it take to do that? And then he did it with helium. You have 4.002602 AMUs. How many atoms does it take to change that to 4.002602 grams? And he went through all the elements that he was familiar with at the time, and it wasn't nearly what we have here, but went through it. And then he took all those numbers and averaged them out. Now he found one thing, that they were very similar in number, which will make sense as we go through this. But then he took an average of all of them and found that value to be 6.02 times 10 to the 23rd. Now that's a rather peculiar number, and it's an extremely large number. It makes sense because atoms and molecules are exceedingly small in their own individual way, but when you put a bunch of them together, this many together, you can actually be able to measure with them. So this was later denoted as Avogadro's number. It was well after he died. In fact, when he first did this, it wasn't accepted by the scientific community, but they later came around to it and understood that he was pretty much right on the money with this. Now, he didn't call it Avogadro's number. That would be pretty arrogant to do that. So he called it the mole. Now this is Italian, so I'm sure the mole has something to do with atoms and not furry little creature that are ugly as sin and eat your garden. He has probably something to do with the atomic level, the molecular level, in my guess. But I don't know. But it's not unusual for some people to give a name to a number. I mean, we've got this all around. For instance, you go to get some donuts, and you're told, oh, go get a dozen donuts. Doesn't give you a number, just a dozen donuts. Well, 12, right? 12 donuts. That is a name for a number. Dozen is a name for 12. Pear, 2, trio, 3. Gross, 144 actually. You can buy a gross of pencils for fairly cheaply, and that's 144 pencils. You get that. And there's another big one that really has come on strong the last 10, 15 years, and that is a googol. Now, you'll notice that Google is not spelled the same way as Google the company. It ends in O-L instead of L-E, and it's not capitalized with the company Google, capital G starts with there. But this is where they get the name from. 10 to the 100th power. They call that a googol. Not Google called that Google, but this is known in some circles as a googol. So that's 1 and the 100, zeros behind it with like about 34 commas, 33 commas. So Google said, well, let's name the company after this because that could be the number of pieces of information that's out there, and we want to be able to allow people to all get access to all the information that we can give them. So that's where they got the name from. It is a name for a number. That's the point. A mole is a name for a number. The number is 6.02 times 10 to the 23rd. Now it will seem a little ridiculous of a number for some of you, but I guarantee after you get done with this chapter and other chapters later on, that will be a fairly well-known number on your part. Okay? Now, what we're going to do in this little thing here is that we're going to be able to look at a periodic table and be able to determine how many atoms there are in a mole of each of these, and because the name mole means 6.02 times 10 to the 23rd, we will know that a mole of boron has 6.02 times 10 to the 23rd atoms of boron. We know that a mole of nickel will be 6.02 times 10 to the 23rd atoms of nickel. We know that a mole of mercury will be 6.02 times 10 to the 23rd atoms of mercury. That's really easy. Where people get confused then is when I ask them what is the mass of a mole. Now, a mass of a mole is the average atomic mass, get the hint, mass, average atomic mass, that is measured in AMUs, but you're going to change it to grams because we're going to assume that we have 6.02 times 10 to the 23rd atoms. And that will weigh this same number, but in grams instead of AMUs. So let's take aluminum as an example. Aluminum's element number 13. Okay? Now, if I want to know how many atoms and the key here is atoms in 1 mole, well, a mole, by definition, is 6.02 times 10 to the 23rd. Okay? Now, if I ask for a mass, it involves this number only that we understand that when we're changing the AMUs to grams, we have to have that many atoms. But the number does not come into the mass. So what is the mass? Of 1 mole. And yes, mole, the abbreviation for mole is MOL. Mole is a 4-letter word, and we get a 3-letter abbreviation. So the question is, what was the point? I mean, is it because you put another E on a word that you're likely to get struck down with carpal tunnel syndrome because it's so painful, you're writing so many loops, and your hand might get into twitches like this, you can't stop, or you have carpal tunnel syndrome. What is the point of a 3-letter abbreviation for a 4-letter word? I don't know, but it is. Anyway, getting back to this. So we go to aluminum, find aluminum up here, and the average the average atomic mass is really massive number. So see what I did, massive number. Aluminum is average atomic mass 26.9815 386. Now, when we do these exercises, I do not want all these numbers. I'm not even going to look at them. I want you to round it off to 3 significant figures, 3 sig figs. And the way you do that, and you've done this before, but let's just make sure we're all on the same page, And this poses a rather interesting problem as well, because students will make mistakes on these kinds of problems as well, so let's try to head that off as much as possible. The first significant figure is the 2, the second one is the 6, the third one is the 9. I want 3 significant figures only on our answers, okay? So we're going to stop there. The problem is that 8 is 5 or greater. So it's going to kick that up to the next number. And this is where people go, oh, well, the number after 9 is 10, so let's say 26.10. No. Here, it actually is 27.0 because you have to put the 0 down and carry the 1. But that is a little, too much processing for some people. So let's take another attack to figure out how to round a number like this. Let's pretend like the decimal point doesn't exist going up to that number right there. So let's just write 269 instead of 26.9, okay? And we know we got to round it up because that's 8. So what is the next number after 269? Well, you got $269 and somebody gives you an extra buck. How much money you got? Yeah, 270. So this becomes 270. But now we put the decimal point back in, be after what was the 6, which is now the 7. And that's our answer. So this answer is going to be 27.0 grams. 1 mole is measured in grams. 1 atom is measured in AMUs, or atomic mass units. You've got to get that distinction. Okay, so when you go through the practice problems, make sure you keep thinking. Number of atoms, 6.02 times 10 to the 23rd. Mass of 1 mole, the AMU of the atomic mass unit, the average atomic mass, AAM, average atomic mass in grams instead of AMUs. Okay, so here are your practice problems. Find the number of atoms for each of these. Find the number of grams of a mole of each of these. So, number of atoms in a mole of each, number of grams of 1 mole for each. So there's 2 answers for each one. One's really easy. The other one you have to do some digging for. And then round off the 3 significant figures as well. Okay? Good luck.